So that's a fugue by Handel. I love a good Handel fugue. Okay, so we're interested here in Demar's theorem, question 9, 3B question 9. For A, to express cos 7 theta, we're just going to start with the cis of 7 theta equals cos theta plus I, so well, basically cis theta to the power of 7, which is Demar's theorem to start with. And so we're looking for the real part of the left-hand side equals the real part of the right-hand side for the cos part. So that's the cos of 7 theta. Now we'll need Pascal's triangle. 1, 5, 10, 10, 5, 1 I'm familiar with. 15, 20, 1, 7, 21, 35, 35, 21, 7, 1. Okay? Those are the values that we're looking for. But I'm hoping that you are familiar with the idea that obviously for the real parts, this is going to be cos to the 7. This is going to involve sine squared, which will get you a real part, or an I sine squared. This is going to involve you an I sine to the 4th, and then the 7 again is going to involve you an I sine to the 6th. So basically what I'm saying is it's cos to the 7th theta, and we're going to ignore plus 7 cos to the 6th theta times I sine theta, because that is obviously imaginary. That's imaginary because there's a single power of I. So this is plus 21 cos to the power of 5 theta, sine squared, sorry, I don't know, we don't need the brackets there actually, cos to the power of 5 theta sine squared. Well, I do need the brackets because I'm just going to, let's just go slowly, shall we? I sine theta squared plus 35 cos cubed theta, I sine theta to the power of 4 plus 7, ignoring this one, plus 7 cos theta times I sine theta to the power of 6. So that's cos to the power of 7 theta. Now it's minus, it's going to be minus 21 cos to the 5th theta outside 1 minus cos squared theta. I squared is minus 1, sine squared theta is 1 minus cos squared. I'm going to move to the next line, plus 35 cos cubed theta, and here I to the 4th is positive 1, but then sine to the 4th is 1 minus cos squared, 1 minus cos squared theta squared, so I'm going to expand that as 1 minus 2 cos squared theta plus cos to the 4th of theta, and then plus 7, so that's minus 7 because I to the 6th will give you minus 1. So minus 7 cos theta outside. That's going to be 1 minus cos squared. So sine to the 6th theta is sine squared to the power of 3. Sine squared to the power of 3. Sine squared theta cubed is 1 minus cos squared theta cubed. So it's 1 minus 3 cos squared theta plus 3 cos to the 4th theta minus cos to the 6th of theta. So now I can maybe slightly skip a step and just factorize, sort of collect, so that, let's be clear what that is. That's the cos to the power of 7 of theta. Outside, well, where are the terms? Well, there's one of them here. This is plus 21 of them there. This is plus 35 of them there. And that's, okay, let's do it. So it's 1 plus 21 plus 35, and then, did I do it? That's there. So that's plus 7, which is 63? No, I'm actually, no, 64. 5, 6, 7, yeah. So 64 cos to the power of 7 theta. Now, I always get these, there's a lot of opportunities for getting these wrong, so I'm just double checking the answer as I go, and it's right. That is 64 cos to 7 theta. So with that little bit of confidence, let's plunge into cos to the fifth theta. Let's highlight that in blue. So 21 of them, minus 70 of them, minus 21 of them. So it's going to be cos to the power of 5 theta, negative 21, negative 70, and then negative 21 again, plus cos cubed theta, which we might highlight in just yellow, cos cubed, so 1 of them and 7 of them. Well, that's easy enough. Sorry, one of them is cos cubed, so 35 plus 21, and then we're left with plus 7 cos theta. The last one we're left with being that one. Okay, so that's all of the terms. Okay, so then we've got 64, 42, so minus 112 cos to the power of 5 theta plus 56 cos cubed theta plus 7 cos theta. I'm checking my 1%. That's a minus 7 cos theta. Yes, so let's just pretend that never happened and hope that no one ever watched this video, which luckily almost nobody watches my videos anyway, so we should be fine. There we go. Whenever I plug in the power, that strange things happen to my pen. Anyway, okay, so we've done part A. Part B is interested in use the substitution x equals, well, they give you the substitution, you can't say further than that. Use the substitution that to show the equation that has roots that. Okay, that's interesting. So, oopsie. I need to paste image, so just the part that I'm interested in. So use the substitution x equals 4 cos squared theta. So you've got, well, cos 7 theta equals, cos theta outside, 64 cos to the 6th theta minus 112 cos to the 4th theta plus 56 cos square theta minus 7. Yeah? So that's not unlike what we've got there, which is cos theta outside. So if we let, obviously, x equal 4 cos squared theta, we're going to get, that's 4 cubed, so that is x cubed. X cubed is 4 cubed cos to the 6th, so minus, so this, maybe we'll just give it, this is 4 cos squared theta cubed. This is, so 112 divided by 16. If I was a better math teacher, I'd know that without picking up my calculator. Minus 7 lots of 4 cos squared theta squared, plus 7, sorry about the writing. If I move it to the left side of my screen, it actually works out better. Oh, see, it works out better the further away it is from the current, I think. 7, 4 cos squared theta squared, plus obviously 7 times 4, 14 times 4. 14 times 4 cos squared theta minus 7. Sorry about that bracket there. Minus 7. Okay, so 4x cubed minus 7x squared plus 14x minus 7 equals 0 when cos 7 theta equals 0, but cos theta does not. Yeah? So cos 7 theta equals 0 when theta equals, so we're looking for, when 7 theta equals, we're looking for places where cos is 0. Cos is 0 at plus or minus pi on 2, plus or minus 3 pi on 2, plus or minus 5 pi on 2, and we're not really interested in 7 pi on 2, I don't suppose. Maybe. Yes, that's interesting. Plus or minus 7 pi on 2. So that's when theta equals plus or minus pi on 14, plus or minus 3 pi on 14, plus or minus 5 pi on 14. Note, obviously, in these places, this is where cos theta equals 0, and we have very clearly stated that we don't want cos theta to be 0. So those are the 6 solutions we're after. So therefore, the roots, the solutions of 4x cubed minus 7x squared. Oh, well, that's a cubic, obviously, yeah. So we need to. That is going to be. Let's just go with x. Was it x equals 4? X equals 4 cos squared theta. Therefore, x. Sorry. Oopsie. Therefore, x equals 4 cos. Well, even just write that where. Need another page, obviously. What's happened? I got the extra page in the wrong place. Where this is true. Where theta equals those things. Which is exactly what we're after. Yeah? Which is exactly what we're after. Although, to be clear, when you do cos squared, so I should have done this. When you do cos squared, you're going to eliminate, the cos of negative theta. So this is really not saved any time. The cos of negative theta is the same as the cos of theta because cos is even, where theta equals pi on 14, 3 pi on 14, and 5 pi on 14. Great. So those are the root. Yeah. I haven't said that very well, but you can see how you get there. Great. So, but then, hence evaluate. So I can probably copy this down here as well. Part 1, the sum of roots of that equation will be cos squared pi on 14 plus cos squared 3 pi on 14 plus cos squared 5 pi on 14. The sum of roots will be 7. Negative b on a, basically. Yes, 7. The negative of negative 7. But then part 2 gets a little bit racy. We're looking for the cost to the 4. How do you do that? Well, I'm hoping you can see if this is alpha plus beta plus gamma. This is alpha squared plus beta squared plus beta squared plus gamma squared. How do you get alpha beta squared plus gamma squared? So I'm hoping you remember from your extension 1 work will be alpha plus beta plus gamma all squared minus 2 lots of alpha beta plus alpha gamma plus beta gamma. Yeah. And how do you get... So how do we get that? This here is, in this case, 7 squared minus 2 lots of... The product of roots 2 at a time is going to be 14. So the cos to the 4th pi on 14 plus cos to the 4th 3 pi on 14 plus cos to the power of 4 of 5 pi on 14 equals 49 minus 28 equals 21. Let me check those answers. Damn it! Oh, really? So on 4, where's the 4? X equals 4 cos squared. Ah, haha. Yes, okay, well, I've been very silly, haven't I? Because these roots are, yes, pardon me, these roots are not at all, I've represented these alpha, beta, and gamma, they're not at all. Alpha is 4. Pardon me, so let's just fix these. This is 4, 4, 4, because x equals 4 cos squared theta. 4, 4, 4 equals 7, so really, cos squared pi on 14 plus cos squared 3 pi on 14 plus cos squared 5 pi on 14 equals 7 on 4. That's a poor mistake. And so really we're probably more interested. Okay, so this is in general a true fact here. Let's just cut this. I think that's just wrong. That summary of things is a true fact. If we just defined alpha and beta and gamma as these, we might be interested in how do we... So what's alpha beta plus alpha gamma plus beta gamma? Well, obviously, I'm saying that is cos squared pi on 14 times cos squared 3 pi on... Let's just... Yeah, let's not... that's going to confuse you more. Let's not call... So these are not what alpha and beta and gamma are at all. And these are not what alpha squared, beta squared, and gamma squared. This is basically... This is here... alpha squared on 4, that's alpha on 4. That's alpha on 4 plus beta on 4 plus gamma on 4. And this is going to be alpha on 4 all squared plus beta on 4 all squared plus gamma on 4 all... beta on 4 all squared plus gamma on 4 all squared. So let's just at least find what we're after. Alpha plus beta plus gamma is 7 squared, and this alpha beta plus alpha gamma plus beta gamma we set from here, so we're looking here, is 14. So that is 21. But we're looking for alpha, so we're looking for that divided by 4, alpha squared plus beta squared plus gamma squared all over 16 equals 21 over 16, which I'm now checking the answers, is correct. But I haven't written the actual working, so let's just cheat. Because I've had enough of this pencil. Look at that one. There you go. And that is that the whole question? That's everything. Okay, so that's how to get through a de Moivre's theorem question of that type. The last part is really just about sum and product of roots and understanding that from polynomials. Also, a little sting in the tail that I got wrong where there's the 4 in that case. Part A is relatively routine with the expansion as we've been doing in class a lot. And part B is really where there's actually some work, but they give you the substitution and then that sort of plays out. You just need to be a bit careful with, you're looking at, if you're trying to solve this equals 0, obviously you're really interested, actually you're specifically interested in this equals 0, and so therefore you're looking for where this is 0 but this is not. Yeah. Okay, so keep at it and keep those questions coming because I'm happy to answer any of them you like.